So this problem states variations in the resistivity of blood can give valuable clues about changes in various properties of the blood. Suppose a medical device attaches two electrodes into a 1.3 millimeter diameter vein at positions 5.3 centimeters apart. And the question is wanting us to solve for the blood resistivity if a 9-volt potential difference causes a 240 microampere current through the blood in the vein. So what we know is the radius of that vein, the length that of the space between where the electrodes are connected, the potential difference, and the current. And we're solving for, once again, that resistivity. So one of the key things about this problem is to not mix up resistance and resistivity. Resistivity is a measure of the resisting power of a specified material to the flow of an electric current. It's not dependent on the same things that R is. So resistivity is essentially a characteristic of the material, whereas R is going to be affected by much more. But with that in mind, you can see with the picture, it's obviously not to scale, but it kind of gives you an idea of what this situation would look like. So our equation for resistivity is R times A over L, with R being resistance, A being the cross-sectional area of our vein, and L being that length of, you can see the length of the vein that we're connected to. So the key thing is that we don't have R, but we can use our V equals IR equation because we do have V and I to substitute for that R and have enough information to then go on and solve. So also you need to plug in any circle, the area is going to be pi r squared, so that's what you're going to be plugging in for A as well. So once you do all that, you get a simplified equation of resistivity equals voltage times pi r squared over current times length. So it's really important to remember to convert all of your units in this, and once you do that and plug it into the calculator, you get a total resistivity of 0.94 ohm meters. So that's the final answer to this question. I think overall it's a pretty simple problem using the equations that we learned from some of these recent chapters. But it can be kind of tricky to remember the difference between resistivity and resistance and all that. But other than that, not too bad. Thank you for listening.